Alright, so today we're going to look at how to solve systems of equations, linear equations, by elimination. Okay, and so when you want to solve by elimination, you're going to have x and y, so you see x and y right here on the same side, and also x and y in the second equation are on the same side as well. And the x's are lined up on top of each other, the y's are lined up on top of each other, the equals and the numbers on the right. So in other words, they're in standard form. Okay, so when you have two equations set up like this, you can solve them by trying to find the greatest common factor, making sure one's negative, one's positive. But in my opinion, the easiest way just to stay consistent is to multiply the top equation by some number and multiply the bottom equation by some number. Okay, that some number is going to come from the number, the coefficient, or in other words, the number connected to the x. Okay, so the first equation in red, we're going to multiply by this number here. So if there's no number that is multiplying to the x, that means there's an invisible 1. So let's just put a 1 up there just so you can see it. Okay, and I'll put a 1 here. Alright, and then the second equation, we're going to multiply by the coefficient, or in other words, the number that's multiplying to the x on the first equation, so that's a 3. Alright, and the next thing you want to assess is one of them has to be positive, one needs to be negative. So if you look at your original equation, you have a positive 3x and a positive 1x. Those are both positive, so we need to make one of them negative by multiplying one of the equations by a negative. And I always just do the bottom one. Okay, so the bottom one here, let's just put a negative on that 3. Alright, good. So on the first equation, if you go ahead and distribute this 1 to everything, well, 1 times anything is itself, right? So this first equation is actually going to be the same. So that's going to be a 3x minus y is equal to 3. Okay? And the next equation, we're going to take this negative 3 and we're going to multiply it across. And the most important thing is to remember is to multiply it not just to the x and y, but also to the number on the other side of the equal sign. Because we want the whole equation to be multiplied by this negative 3, or else we're changing the equation. Okay, so negative 3 times 1x, that's going to give you negative 3x. Negative 3 times positive 3y is going to give you negative 9y, and that is equal to negative 3 times 11 is going to give you negative 33. Okay, so now we are set up to add these together to eliminate. So you see how the x on the first equation is a 3x, and the x on the second equation is a negative 3x. They're both the same number, and one's positive, one's negative, so when you add these together, so think about putting a plus sign there. When you add these together, the 3x plus negative 3x, or in other words 3x minus 3x, that's going to eliminate, so those go away. Now you have negative 1y minus 9y is going to give you negative 10y, and that is equal to 3 plus negative 33, or in other words 3 minus 33, it will give you negative 30. Okay, and the last step to solve for the y is to divide by negative 10 on both sides of the equal sign. Negative 10's cross out there, so now you got y is equal to, the negatives cancel out, makes it a positive, so a positive 3. 30 divided by 10. Okay, so that is half of your answer. Remember, when you have a system of equations, you always want to find both the variables, unless the problem tells you only one of them. Okay, so we found the y, now we need to find the x. So what I always do is I always take the top equation, just to stay consistent. We don't have to use a top equation. So you want to take this 3 and plug it in for the y in that top equation. Okay? Once again, you do not have to use the top, you can use the bottom. I just find it easier to stay consistent. So 3x minus y is equal to 3. And notice how I'm using my original equation and not the one that I transformed. So that way the numbers are smaller and it's a little bit easier. Okay, now 3x minus y is equal to 3. We can plug in the 3 for the y because that's what we just found. So now we have 3x minus 3 is equal to 3. Okay, that's a lot of 3's. Alright, and then the next step is to add 3 on the left side, add 3 on the right side. So now you are going to have, if you add these together, 3x still on the left. Those 3's cancel out. You got your equal sign, and then you got a 6. And the last step here to get x by itself is to divide by 3 on both sides. Now you get x is equal to positive 2. Okay, so as long as you have an x and as long as you have a y, you have a solution. And anytime you write a solution for an equation that has an x and a y, you always want to put it in coordinate form, meaning x comma y, because remember the solution to a system of equations is where those lines intersect. So where these lines intersect is at one coordinate. They won't intersect in two coordinates because of two lines, and so they will never turn back around. Okay, so the first coordinate is x, and that is going to be 2. And the second coordinate is y, and that is going to be 3. So here is your solution to this system of equations. Alright, so here's all that work we just did. And now what I'm going to do is do one more problem just so we can get an equation or two equations that you're going to multiply by something other than 1 on the top. Alright, so here's this next equation. We once again we have the x here and the y here, and on the other equation we have the x and the y also on the same side. You notice how none of the numbers are the same on the x's or on the y's, so that means that we're going to have to multiply. Okay, so the top equation, you're going to multiply by the number that is the coefficient or the number that's multiplying to the x on the second equation, which is a 2. Alright, and then the bottom equation, you're going to want to multiply by the top coefficient that's connected to the x, or the number that's multiplying to the x in the top equation, which is 6. And notice how both these numbers, the 2 and the 6, are positive in your equation. So that means that you need to have one of them negative, and like I said before, I always do the bottom one just to stay consistent, less likely to make an error. Okay, so now we're taking the 2 and we're distributing it all the way across to the other side of the equal sign as well. So your new transformed equation is going to be 2 times everything. So 2 times 6x is going to give you 12x. 2 times 5y is going to give you positive 10y. And that is equal to 2 times negative 2, and that's going to be negative 4. All right, very good. And now the next equation, negative 6 times 2x is going to give you negative 12x. Then negative 6 times 3y is going to give you negative 18y. Bring the equal sign down. Negative 6 times positive 6 is going to give you negative 36. All right. And now we can add these together, because if you look at the 12x here and the negative 12x there, we're adding them together. Those are going to eliminate, or in other words, when they add together, they equal 0. So that variable eliminates. Okay, so put a dash to that. And so if you can notice that the method I'm using, I'm always eliminating the x. And so if it's easier for you to always have the same steps every time, then always do this, no matter what. So you're always going to be solving for the y first. Okay. All right, so when you add 10y and negative 18y, you are going to get negative 8y. And that is equal to negative 4 minus 36. Since both of these are negative and we're subtracting it, that means that it gets more negative. So we have negative 40. Think about it having negative 4 negatives and 36 negatives. When you add all the negatives together, you get negative 40. Okay, so negative 8, divide by negative 8 on both sides, divide by negative 8. Okay, so the negative 8's crossed out on the left. Now you have y is equal to, the negatives cancel out, so that's going to be positive 5. Okay, good, we found half of our answer. Now we need to go back and find the other half, the x. And once again, I always use the top equation. Okay, so let's rewrite that equation. 6x plus 5y is equal to negative 2. I know what my y is. The y is 5, so I can substitute that in. So 6x plus 5 instead of 5y. You got 5 times 5 is equal to negative 2. All right. And what is 5 times 5? It is 25. So 6x plus 25 is equal to negative 2. And some of you might be able to see this is not going to be a very nice problem. It's going to give us a fraction or a decimal, but that's okay. We can get that in math class. So now we're going to subtract 25 on both sides. Subtract 25. And that is going to give us, now 6x is left on the left side, is equal to negative 2 minus 25. Once again, you're getting more negatives since you have two negatives and you're subtracting them. That's negative 27. And then when you divide by 6 on both sides to isolate that x, I'm going to go over here to have more room. You get x is equal to, you want to either reduce this fraction or you can divide it out and turn it into a decimal. So the reduced fraction is you divide both numbers by 3. That's the common factor there. And so that's going to be negative 9 over 2 or negative 4.5. I always like leaving my answers in the fraction form unless obviously I have to turn it into the decimal. Okay, so always leave it in the fractions because that's always going to be the exact answer. So if I can squeeze my final answer, let's squeeze my final answer here in the middle here. We have the x is negative 9 over 2 and the y is 5. So the coordinate, let me put a different color here. The coordinate is going to be the x, which is negative 9 over 2, comma the y, which is 5. Okay, once again, you can do negative 4.5, comma 5 if you desire, but I always like leaving it as a fraction. Okay, and that completes our lesson for today. Thank you.